Given an array of strings, we have to return the longest prefix that all the strings have in common. For example, if the words are flower, flow, and flight, the longest common prefix is FL. Now the strategy we'll take here is a vertical scanning approach. So first, we look at the first character of each word and see if they all match. If they do, then we'll move on to the second character and see if they all match. Then we look at the third character, and here we notice that the prefixes become different. There is a mismatch between O and I. At this point, we'd end the algorithm and just return FL. The nice thing about vertical scanning is that it doesn't do any extra work, even if one of the strings is much shorter than the rest. For example, let's say the words are accompany, accomplish, accompanist, and then just the word A. Clearly, the longest common prefix is just A, even though the first three words are very long and have a longer common prefix between the three of them. With vertical scanning, we look at the first character of each word, A, and confirm that they all match. Once we get to the second character, we notice that the word A has run out of characters, so we just end here and return A. Now let's see how we can implement this in Python. Let's assume that the input array contains the strings flower, flow, and flight. First, we'll handle the case that the array is empty by just returning the empty string. Then we'll take the first word in the array and call it base. So here it'll be the word flower. We call it base because we'll compare every other word in the array with this word to make sure that the prefixes match. It actually doesn't matter which word you pick here, but it's just easiest to pick the first word in the array. We'll then enter a loop that will traverse through each letter of the base word using the counter variable I, which will be the index of each character in the string. We'll then enter an inner loop, and this loop will use a variable called word to traverse through all the different words in the array. This part here means that we'll start from index 1 of the input array, so in other words, the second word in the array. This is because we're already using the first word in the array as the base word, so we don't need to compare it to itself. So word will first start out as flow. Then we'll check for two things, and if either of them are true, we'll return early. First, since I is the index of the character we are comparing, we'll check if the index is out of bounds for the current word we're on. Remember, since indexes start with 0, if I equals the length of the word, that means we're already one index past the last character in the string. Right now I equals 0, and the length of the word flow is 4, so this isn't true. The next thing we do is compare the character at index I of the base word, flower, with the current word we're on, flow. Right now you can see that the character of both words at index 0 is F, so this condition is false, and we can move on to the next word in the array. The next word is flight, and again we'll compare the character at index 0 with flower. Both characters are F, so now we exit the inner loop and we'll increment I in the outer loop. Then we'll do the same thing again, but this time comparing the second character in the strings, or the character at index 1. The word variable will, again, start off as flow, and both characters at index 1 are L. The next word is flight, and again, both characters at index 1 are L. This means that we can move on to the third character. Now, both flower and flow have O at index 2, but when we look at flight, we notice that the characters are different. That makes this condition true, so we'll enter the if block. Now that we know that all the characters are the same up until the character at index I, we can slice the base word and only return the characters up to that point. Remember that when using this slicing operator, the first index is included and the last index is excluded. So since I equals 2, this returns the characters from index 0 to index 1 from the base word flower. So we end up returning the string FL, which is the correct answer. Now let's look at another example where one of the words is very short. Now let's say the words in the array are action, actors, and A. We'd start out the same way by taking the first word, action, as the base word. Then we'll start iterating and compare the first character in action with actors. Then we'll compare action with the word A. All of them start with the letter A, so we'll move on to the second character. The second character in action and actors is both C, but now when we look at the word A, the I index is equal to the length of the word, which is 1. This means that we're out of bounds, so this part is true and we'll return early. We'll return the characters from index 0 to 1, but excluding 1, So in other words, this only returns the first character, which is A. So this is why it doesn't matter which word we pick as our base. We automatically finish the algorithm when the end of the shortest word is reached. Now, what about this last part at the end? Well, if we get to this point, that means that the entire base word was the longest common prefix. Let's do one more example to demonstrate this. Let's say the words are go, goals, and govern. Go becomes the base word, and we'll loop through and make sure that all of them start with G. Then we'll look at the next character and make sure that they are all O. At this point, the outer loop ends since we've traversed the entire base word, and we go to the last line of code. At this point, we know that the base word is the shortest word, and the base word itself is the longest common prefix. So we'll just return the base word, go, and we are done.